Hello and welcome to the next chapter of KNX Advanced course. It is called Logic Operation in KNX. Now we are going to learn more about how we can define logic in KNX. It means the devices based on KNX and what beneficiary it provides for us. Thank you so much for your attention. My name is Amir and I hope you will enjoy it. Okay, so why we learn logic? Or the best question is why we need logic? A large number of functions in building control system or building management system cannot be traced back to only single circumstances. Functions or states of devices or circuits are frequently made dependent on several conditions. It means there are some functions, or sometimes there are many functions in building automation that needs to be operated based on some specific conditions, okay? Because we have the smart system, so our system should make the decision based on some condition. And when we talk about the condition, it means we should apply the logic to our automation, and it's better to say to our building automation systems. The logic operation of various trigger factor can be implemented in various ways in KNX system. Different solution can lead to the objective depending on the type and number of required conditions. The KNX components that are available on the market from various manufacturers, okay? For example, from ABB, Schneider Electric, Siemens, Hager, and all of them provide a range of variants which enable frequently requested logic operation to be implemented. The group objects and parameter setting of these devices use the basic principle of digital technology. So it means when we want to define the logic in KNX devices, okay, we should do it from the parameter, and according to our parameter setting, it provides for us some specific group objects, and then we will link the group objects in a manner that provides us some specific logic, okay? But remember that this is only one of the way to provide logic in KNX, and we have the other way. So let's go and see. So in KNX, when we want to define the logic or apply the logic, for most of the time there are two ways. First of all, we can define it in ETS or based on ETS. It means we do not need any extra software for it, okay? So when we want to define in ETS, there are two ways. One of the way is we use the logic module. So some companies like ABB, Schneider Electric, and some other companies provide us the logic module. It is some module, we install it in the electrical cabinet. There is no any physical digital input output on it, but inside of it there is the logic operation. So we add it to our ETS and follow the manual to define the new logics. There is another way is to use the embedded logic inside of some devices, okay? I mean the devices like the actuators or sensors, okay? So nowadays, especially nowadays, most of the KNX devices provide us some logics, some free logics in their devices, so we can use it, okay? This is the first way to define the logic. Also, there is another way is we use the server or mini server in KNX, and inside of it we use that specific software to define the logics, okay? For example, you use the SpaceLink from Schneider or Comfort from ABB or the home server from Divus or many other server or mini server devices, and you define this the logics, the conditions in that software, and use the output to control the KNX devices. So what are the benefits or what are the drawback of these manners is, I can say, if when you use the embedded logic in ETS, based on ETS in KNX devices, you do not pay anything, okay? So it's free. But for server or mini server, you should pay the money for the software, so it's extra money. Then when you use the software, okay, you can define for most of the time unlimited logics, but in ETS you have the limitation. When you define the logics in ETS in embedded devices inside of it, and you lose some of the devices, still some other logics will be operated, okay? But when you define the logic in server or mini server, if you lose the server or mini server, you lose the logics. So there are pros and cons, or advantage and disadvantage of using this. For most of the time, if you have some limited logics, you are going to use the ETS logics in embedded inside of the devices, okay? And if you have the big project or very big project, or you need many logics, you are going to use the server. But this is only some recommendation. You are free to choose. Okay, so here you can see the view of Xlogic editor in the server from KNX Automation Austria. It's the best software among the KNX products around the world to provide us the stable server solutions. So you can see here from the graphical functional block, you can apply the logics. Okay, great. The other way is to use the ETS. So inside of the ETS, in parameter, you can choose the enable, for example, function of the logic, and then go inside of the logic and start to define the different logics like and, or, and many other things, okay? The companies who provide us nice logic operation is Zenio, in my point of view, Teben, ABB, and so on. Okay, so here the book said when you buy the switch actuator, okay, the digital output with the logic function inside, you can use the logic for free and programming in ETS. Of course, when you use the group object for the switch, it provides us some similar operation like OR. For example, you connect the group object of the switch in a group address, and you can send from one sensor the command to switch on and off, or the command from another sensor, for example from two keypad, okay? So it is possible. But the book said when you use the inside of the logic embedded in the device like switch actuator, you can define the new logic, as this picture show you in the previous slide. Yes, okay. But when we talk about the logic which is embedded, it means via the function logic operation, it is possible to link the switching of the output with the specific condition, the following can be selected. For example, most of the time we have the AND function, OR function, XOR function, or gate function. Two logic objects are available. Switch object is the first of the all evaluated with the logic operation one group object. Here, for example, we have the switch object, the output of the switch object, okay, digital output as the input of the logic. The result is linked with the logic operation 2. For example, we have the input from the logic, okay, we input it to the logic like AND, OR, XOR gate, okay. Then the activation of the logic function means that the switch object of the respective channel output interacts with the logic object of the associated channel output. For example, we have another group object logic 2, and then the new logic operation, and we will have the output. So what it means we can in ETS we can use the logic operation in parallel, and for example we use the output of the switch as the input of the logic. We use the extended new input and then apply the logic, use the result, and then compare the result with the other input of the logic and apply the last logic operation, and we will use the output. Okay, so it is possible in ETS. But when we say this, it means we should do some parameter setting and then have the group address for the two input, and then have the group address for the output, and then have the group address for the compare the second logic, and have the group address for the outputs. Okay, so in KNX we use the parameter and group address to define the logic in ETS. Okay, in the book for this chapter, now it's going to provide us some example to show us what is or and so on. Okay, so here in parameter you choose, for example, for logic operation the type of the logic operation and it means when you have the switch object as the input and logic operation as the input, your output will be something according to your choose. Okay, for example, you choose OR, so this one is 1 or nothing is 1, okay, or nothing or 1 is 1. And from here, when the input is 1, when the input is 1 here as a input, and here the input is nothing, the output is 1 because this is OR. Okay, you can go through it in the book and try to more understand. It is so simple. Also, we have the OR with on-off delay. Okay, it means we have the delay 1 and delay, and we have nothing. Okay, and there is an output. Remember that the book said for the different manufacturers, okay, the behavior of the output it's differ when you have the delay. You should go to the manual and see when the input has the delay for the on delay or the off delay, how it applies. For example, in this example, the on delay is not applied in OR, okay, but the off delay is applied in OR because when we have the off delay as a input number 1, and when we have nothing as input number 2, we have 1 as the output, okay, for off delay. But maybe in some other manufacturers it will change. So when some concept like delay is applied to the OR and so on, you should check the manual of the devices and figure it out and figure it out, or see how the device behavior in case of the on or off delay. Okay, Okay, when we have the AND, it means for input number 1 we have 1 here, for input number 2 we have nothing, and the output is nothing. Okay, but when the input number 1 is 1, input number 2 is 1, because this is AND, the output will be 1. Also, for the AND with on-off delay, we have we should check the behavior of the manufacturer. Okay, so here, for example, the on delay and with 1, the output is nothing. Maybe in some another manufacturer it will be different. And for example, for off delay and 1 is 1. So you see, this is something special in KNX, and for the devices from manufacturer by manufacturer, when the delay concept is applied, it will be different. Okay, extended logic or direct relay control. Here the book said when you use the logic operation inside of the devices in KNX and have some settings in parameter, there will be 2 type of outputs. Sometimes the logic output or result is applied to the output of the switch. So look at this group objects. We have 3 inputs, okay, and we have 1 output. So the output of the devices is then will be with the same group object of the logic, and the logic which you define is applied to the output. But maybe in some other devices we have the switch object as an output and we have the logic output. Okay, so in my point of view, this is something much better because you have the flexibility to control your digital output with the extra group object, and you have the logic output as a next group object, and you can define and choose and do whatever you want. Okay, for example, you control your switch object from some group address and some operation, and have the logic output from that device. Okay, good. Logic connection of a group addresses. In many building functions, there are a variety of tasks that are defined by various group addresses and must be linked together. The requirement can also arise to combine several group addresses into a new group address due to the limited number of associations in the group object. There is the requirement for other applications to be able to address several group objects with the various bit widths, 1 bit, 8 bit, at the same time with the transmitted address. Furthermore, various applications have a time-limited functions which must be made possible by filtering group addresses. Okay, so we do what we need based on group addresses. Okay, now we want to do some example in KNX Virtual and see how it works. I hope the KNX Virtual will work. Okay, so here we add the 3 devices from the KNX Association products from the catalog view, the logic module, the clicks, that is a push button, and the switch actuator. Okay, so here I would like to change the group address 111 to 11, for example 15 for logic. The clicks, I put it line 1110, and the switch actuator I put it like 1. Okay, great. So how it works, we want something that I want to show you. Okay, here this is the clicks. Okay, we want to define if I press the push button number 1 and press push button number 2, then the channel number 1 will be on. Okay, so to control the channel number 1, we need to make the operation of push button number 1 and 2 with the AND logic, and we will see how it works. Okay, in clicks we have the channel number 1 as a switching, great, and we have the channel number 2 as a switching. And switch actuator, we have the channel number 1 as a switching. That's it. For logic, what we need is for channel number 1, we should define what logic we need, OR, AND, XOR, or no function. We pull it AND, okay, and we do not want to invert or make the output vice versa. Okay, so the not inverted is fine for us. When we assign this, when we go to the switching, you can see for the channel number 1 in logic module, we have 2 inputs, channel 1 input 1, channel 1 input 2, and 1 output. It's here. Okay, great. So now we are going to define the group addresses. Okay, from here, go to open new panel, group addresses. Okay, at the main group addresses, for example, floor number 4, then in floor number 4, middle group addresses, for example, central functions. Then here, what we need the logic operation input 1. Okay, the logic operation input 2. Input 1 will be linked with the push button number 1 and push button number 2. Okay, and then we have the logic output, that is the AND operation. Okay, for the logic operation, this is input 1, input 2, and this is the output. Great. For clicks, we need this one as an input, and we need this one as an input. And for switch actuator, we want to switch on off the channel number 1. Great. Now we are going to download it. Let's let's connect it to the KNX Virtual. Okay, now the ETS number 6, it's detect the KNX Virtual. We select the interface and do the download. All these download all in KNX 6, in ETS 6 is full download in ETS 5. Okay, so now we are going to download it. This is a device number 14, device number 14. And then clicks, device number 4. Okay, we download all of them. We can see the green tick, it's done here. Then we go to the base of KNX Virtual and we will see what's happening. If I push 1, you see nothing happen. If I push 1, nothing happen. But if I push 1 from the push button number 1 and push button number 2, this is changed to on. Okay, so the AND logic is operated. You can see we do it with the parameter setting and group address definition. Okay, if I pick up one of the input input condition, it will be off. Okay, so off. Okay, now if I put 1, nothing happened, but I should put the push button number 2 on to make the AND operation done. Great. So you have seen how we define the very simple logic by using the parameter setting and group addresses definition in KNX. Great. Okay, logic module. The logic module that are available from various manufacturers offer a range of parameters of managing the logic operation mentioned above. Okay. Problematic situation. So before we go to the problematic situation, let's see what is the shape of logic module. Okay. We search in Google logic module KNX and you can see the logic module, for example, from MDT, Germany, from the Schneider Electric, Germany, from the ABB, Germany. Yeah, of course, we have the nice product from the embedded system, Latvia. It is a mini server, quite nice product. We have the product from Jira that is provide for us the logic, and so on. You can see there are many different products when you search the logic module in KNX. Great. So let's continue. So we have the problematic situation when we want to define the logic. We should take care of something important, okay? First of all, telegram transfer times. When using status response objects, it should be noted that problems can be caused by the transfer times of the telegrams. So the frequent getting the sample, okay, from the logic, or it's better to say the transfer time of the telegram or packet of data when you define the logic, it is so important in some specific situation. Telegrams may no longer arrive at the same time due to the time adjustment, so that the logic result at the gate may be incorrect. For example, you want to do something special when the fire is happening in the building, okay? You define the logic. The one input is from your fire alarm system and one input from your some secondary sensors, and then you have some specific output. Okay, so for a specific operation, it is so important the telegram transfer time. You should take care of it. Okay, because of this, we want to think about or talk about more about cyclical sending. The cyclical sending of the sensor can have serious consequences if they are led via logic operation, which then cannot carry out cyclical sending themselves. By way of example, an alarm trigger function should be disabled or enabled via a gate in the same way as a watchdog circuit. If an AND function is set for this input, an alarm would pass through to the other input exactly once. The inputs are, however, sometimes set for cyclical sending to compensate for possible transmission errors caused by repetition. It is important to know here that in contrast to PLC gates, KNX Logic gate module can also send cyclically. It means function practically only as a transparent converters. So the book said we have the cyclical sending from the output. Okay, so it is important to take care of this cyclical sending and see if you need it in your logic operation or not. And about the time. So two things are important. First of all, the telegram transfer times, and then the cyclical sending. Each KNX installation has its own requirements. The application possibilities on a logic module are shown as an example in here. In the picture you can see. The logic module offers functions which are not possible with sensor and actuators alone. Okay, so in B4, when we do not have the logic embedded in sensor and actuator, we have used the logic module. Also we use it today. But carrying out 3 different functions at the same time, like for example logic, their show value, and scenes, all the additional function can generally be carried out in a small KNX installation with the logic module. The logic module, for example, makes different functions available in a device for a special logic operation between sensor and actuator. So the logic module is like is assumed as a controller in the KNX systems. It means it accepts the inputs, okay? It communicates with the sensor and actuator, manipulate the data, and provide us some specific output. Great. For example, in this picture, you can see we can define 12 logics, okay? Logic number 1 to 4, logic number 5 to 8, okay? Or more, as the book said. Okay. So we have some concept in logic definition. Now we want to talk more about it. Okay, first of all, behavior of the inputs. We should define the behavior of the inputs when we do the setting of the parameter. After receipt of a telegram, all the input first save the values in order to make them available, for example, for logic function, for the further processing. When a new telegram reaches the input, the values are overwritten accordingly. You have seen the values were overwritten when we use the input number 1 and input number 2 in our example in KNX Virtual. But we should take care of the behavior of the inputs in the parameter setting. A disable object. Okay, what is a disable object? Disable objects always block the function on receipt of an on telegram at the group address object, disable. On receipt of an off telegram at the group object, disable. The function is enable. Okay, so we have the disable object. It means you switch on and off the logic, for example. Send delay. The send delay indicates how long the logic module waits, depending on the parameterized send condition, before it sends a new values as an output telegram. Okay, you have seen for delay on and delay off, we have the different behavior for the different from the products from the different manufacturers. Okay, so the send delay is also important in most of the case when you want to define the parameter setting. The cyclical sending, we have consider it as something problematic. We should take care of it. Some functions of the logic module enables the cyclical sending of an output values. Okay, it means, for example, each 5 minutes we have the output from the logic module. Okay, the set cycle is then maintained until an output value changed. When a value is changed, the output is immediately sent and the next sending cycle is started. And data type and data point type, it is also important because the input and output can be vary in the data point type, the size, and so on. Different data point can be selected for some functions of the logic module. The data point type is applied where applicable. Always you can go to the product from Zenio. They are so nice in the logic module in their devices. I think the most complete one I've ever seen is Zenio for the logic inside of the KNX devices. Okay, now we want to consider some logic operation. Okay, and we will see how they are operated. We start with format converted. One of the logic operation that is provided in KNX devices is format converter. Okay, for example, you have the 1 byte data, useful data, and you want to turn it to 1 bit or vice versa. It is possible with format converter. As I said, for example, in Zenio, you can see it. Of course, in the logic module from ABB and Schneider, you can see it also. If format converter is selected as a function in general parameter, a line appears in ETS parameter window. It means here, okay. The function is always prefixed with the name of the line for which the format converter has been selected. Great. So with format connector, you can see we have the specific group objects that will be appear. So for example, we receive the telegram in 1 byte and we have some output, okay. 1 byte or 8-bit, we receive it and we have the output bit by bit, for example, okay. It depends what's happening in that device in the manual, it's set. The next one is logic gates, okay. Gate like AND, OR, XOR, and so on. We will we have some example in KNX Virtual. It is like that. This is another logic operation. Most of the time the devices provide for us. The next one is minimum maximum value indication, okay. So this is for the comparison. If the function minimum maximum value indication is selected in general window, here you can see it is selected, okay. The line appears in the ETS parameter window, which carries the name of the selected items. With the minimum value indication, the largest temperature value, for example, is determined from the 2 sent telegrams. For example, 2 inputs are sending, and the larger is selected as output. This value from the different sensor can then be passed to a temperature controller as a measured value, okay. For example, you put 2 temperature sensor out of the building and you want to make the decision of the temperature controller or thermostat based on the higher temperature. So you use the minimum maximum value indication or some comparator, and you make the decision automatically, or the system make the decision automatically based on the data from the sensor. Each of them is bigger, that one will be considered. The threshold value, most of the time in most of the devices it is provided, okay. Especially for sensor, for example, sensor from Elsner Electronic or Teben or other devices always provide us the threshold value. You can see it in the weather station devices. If a threshold value is selected, the new line will be appear. The function is used to detect if the value exceeds fall below a set threshold value, the temperature. For example, it says if you have some value more than some specific value, some things happen. For example, the temperature of a cold store can be, for example, be monitored for maximum value and message sent when it's exceeded. You have the data center room, okay, and you said if the temperature of the data center is more than 18 centigrade, I want to get the notification in my phone. So some alarms should be triggered. So you use the threshold value, the temperature sensor is read the value, and we will have the output based on the threshold value. The next one is temperature comparator. So this is something special only for temperature. It is a comparator. It's like minimum value, minimum maximum indication value. For example, 2 temperature value can be compared with a temperature evaluator. Different telegrams can be sent depending on the results. Okay. In Elsner Electronic, we have the temperature comparator in the thermostat. I've seen it. Gate filter. If a gate filter is selected in general window, 2 lines appear, okay? For example, gate filter number 1, gate filter number 2. The filter function enables the filtering out of the telegrams. Telegram can be routed or blocked with the gate depending on set condition. So this is going to block or let the telegrams routed through the KNX bus. Note the gate filter functions operate at the format level of telegrams. It means 1 bit, 1 byte, 2 byte, and not on a data point types. The book said this is only based on the format, the size, not the data point type. An assignment between the object, it means for 2 byte you have the Kelvin, you have the centigrade. For temperature you have the Fahrenheit. It is not based on the data point type, it is only based on the format, 2 byte, 1 byte, okay? An assignment between the object and the data point is only carried out due to the context of ETS project in which this function is used. The next one is the function staircase light. If the function staircase light, the new line will be appear. The staircase lighting function mirrors the staircase lighting timer. On receipt of an on telegram, the delay is started, and off telegram is sent to the group object at the input once the delay has elapsed. The next one is multiplier. If a multiplier is selected in the general window, the new multiplier line is appear. The multiplier can be used to pass on several telegrams to the output and recipient of a telegram at the input. The output telegram can be 4 1 bit and 4 1 byte telegrams. Okay. So here we want to see how the multiplier is work. With the parameter reaction of the 1 byte output, it is defined how a binary output of the multiplier should behave. The option as an input telegram corresponds to the function of the simple multiplier. The outputs can, however, also be inverted or only react to a telegram. For example, the option sends if on causes a telegram to be sent to the input while an off telegram causes no reaction on the output. The group object example showed that 1 bit input address can send 4 1 bit output addresses and 1 byte output addresses on the bus. The next one is toggle value. If a toggle value is selected, the new line is appear. With this function, a preset setpoint value can be sent as a reaction to the 1 bit input telegram. It is therefore possible to predefine a setpoint for the room temperature. When you are present, it's 20, and when you are absent, it's 18. For example, you use the presence sensor in room. Okay, when the presence sensor detects the people, it's toggle to 20 centigrade. When there is no one in the room for winter season, it is 18 centigrade. Okay, so some toggle is happening. So but the group object 1 bit is provide us this output. Okay, so you stimulate or trigger 1 bit with the toggle value in the logic operation. The next one is the counter function. Means counting. So if you define or assign the counter function, the new line is appear here in parameter. The counter is a telegram counter. Group addresses telegram from the sensors and actuators can thus be counted. The counter can retrigger a telegram maximum every 30 milliseconds. The next one is time delay. If a time delay has been selected as a function in the general window, the new line will be appear. The time delay can be used for 1 bit telegram as an on or off delay. For all other data type, it is used as a send delay for telegram. This telegram delay causes the delay to be started when a telegram arrives at the input, and the telegram is only passed on once the period has elapsed. Okay, this is on-off delay. We already have talked about it. If a further telegram with a different value arrives during the delay, this new value is passed on the end of the delay period. Please Go to the manual of the device if you want to learn more about the delay about your specific device. It is so important. And graphical users provide sometimes, for example, if you use the ABB logic module, it provides you the graphical user. If you use the software based on server or mini server products in KNX, you have the graphical interface. This is graphical interface. It's for parameterization of the application unit shown in the example in ETS. Okay, it is directly into the ETS. So this picture that book provides for you is only I think it is linked with the ETS parameter, and ABB has this feature. But for software, it is not. When you use the software graphical interface, it is not connected with the ETS anymore. If you use, for example, software from the KNX Automation or SpaceLink or some similar products, it is done in that software specifically. Okay, it is not connected to the ETS parameter. So here, when you connect it to the ETS parameter, it is directly integrated into ETS program and can therefore be operated in the usual ETS environment. The required function module are dragged onto the ending surface via the drag and drop, and required connections are linked together by pressing the left mouse button. Clicking with the right mouse button on a module opens up the parameter editing. Yeah. That's it. Thank you so much for your time. I hope you have learned something important. You can use the logic module from the KNX Association in KNX Virtual to learn more, but it is so simple. For more sophisticated, you can go to the products like the product from Zenio or ABB, Teben Elsner, and learn more about it. Of course, for software, always you can go to the KNX Automation software. It is quite nice, or mini server and server from the Schneider, like the SpaceLink and so on. Thank you so much. Have a nice day and see you in next chapter.